Have you ever looked up at the sky on a sunny day and wondered, why is it blue? It's a question that has intrigued both children and adults alike for generations. It's a simple question, but the answer takes us on a fascinating journey through the world of light and color. The blue sky is a result of complex interactions between sunlight and the Earth's atmosphere. We often take the sky's blue hue for granted, but there's a scientific reason behind this beautiful phenomenon. It's called Rayleigh scattering, where shorter blue wavelengths of sunlight are scattered in all directions by the gases and particles in the atmosphere. Every day, above our heads, sunlight is performing an incredible light show. From dawn to dusk, the sky changes its colors, painting a mesmerizing canvas. This show, invisible to our eyes, holds the key to understanding why the sky looks the way it does. The scattering of light by molecules and small particles in the atmosphere is what makes the sky appear blue. So, get ready to explore the science behind blue skies. Join us as we uncover the secrets of our beautiful blue sky and the wonders of light. Sunlight might look white or yellowish, but it's actually a mixture of all the colors of the rainbow. Think of it like a prism splitting sunlight into a beautiful spectrum of colors: red, orange, yellow, green, blue, indigo, and violet. Each of these colors has a different story to tell. These colors travel together as white sunlight until they encounter something that splits them up, like a prism or even tiny particles in our atmosphere. That's when the real magic happens, creating the colorful world we see. Now, each color in the rainbow has a secret code: its wavelength. Imagine wavelengths as the distance between two waves in the ocean. Red light has the longest wavelengths, like gentle ocean swells, while violet light has the shortest, like tiny ripples. All the other colors fall somewhere in between. These wavelengths are important because they determine how light interacts with the stuff it encounters, like air molecules in our atmosphere. And this interaction is what gives our sky its beautiful blue color. As sunlight enters Earth's atmosphere, it bumps into tiny air molecules, mostly nitrogen and oxygen. This encounter causes the light to scatter in all directions. This scattering, called Rayleigh scattering, affects different colors differently. Remember how blue light has shorter wavelengths? Well, it turns out that shorter wavelengths are scattered more strongly than longer ones. So, blue and violet light get scattered all over the sky, making it appear blue to our eyes. It's like a cosmic game of billiards with light. Section 5. Our eyes in the ozone layer, a blue sky team. But there's another piece to this puzzle: our eyes. They play a crucial role in how we perceive the world around us. While blue and violet light are scattered the most in the atmosphere, our eyes are more sensitive to blue light. This sensitivity is what makes the sky appear blue to us. This means we perceive the sky as blue rather than a mix of blue and violet. It's a fascinating interplay of light and vision. And don't forget the ozone layer. This layer is essential for our protection. This protective layer in our atmosphere absorbs most of the harmful ultraviolet light from the sun, shielding us from potential damage, leaving the beautiful blue light to reach our eyes. This light is what gives the sky its stunning blue color. It's a team effort to create the blue sky we know and love. The collaboration between the ozone layer and our vision is truly remarkable. Section 6. Why not violet? A colorful mystery solved. Now you might be thinking, if violet light scatters even more than blue, shouldn't the sky be violet? That's a great question. Let's dive deeper into this colorful mystery. And the answer lies in a combination of fascinating factors. Firstly, the sun emits less violet light than blue light. This means there's simply less violet light available to scatter. Secondly, our eyes are more sensitive to blue than violet. Our vision is tuned to pick up blue light more efficiently. Finally, even though violet light scatters more, some of it gets absorbed by the upper atmosphere, particularly by ozone. This absorption process leaves blue as the dominant color we see when we look up at the sky. It's like a cosmic color competition, and blue light wins. So next time you gaze at the sky, remember the science behind its beautiful blue hue. Section 7. Sunrises and sunsets, a fiery farewell. As the sun begins to set, its light has to travel through more of the Earth's atmosphere to reach our eyes. This means the shorter wavelengths, like blue and green, are scattered away even more, leaving the longer wavelengths, like red and orange, to dominate the sky. That's why we see those breathtaking red, orange, and yellow hues during sunrises and sunsets. It's the grand finale of the sunlight scattering show, a fiery farewell as the sun dips below the horizon. So the next time you gaze up at the blue sky, remember the amazing journey of light and the science that makes it all possible. Keep asking questions, keep exploring, and never stop being curious about the world around you.